Welcome to the Hitchhiker's Guide to Calculus. My name's Kevin, and I'll be your guide to Chapter 1.6, Evaluating Limits Algebraically. Part 1 of this lesson is going to be what everyone should do all the time. When you're evaluating a limit, you should just plug and chug. Most students forget to do this, and they sometimes run into issues because of that. So let's look at a few examples. If you have the limit as x approaches 3 of 2x squared minus 4x plus 1, first and foremost thing you should do, try to plug in 3, just like it's a normal function when we're evaluating f of 3. We plug it in, we get 2 times 3 squared minus 4 times 3 plus 1. Simplify that, that's 9 times 2, 18, minus 12 plus 1, and we should get 6 plus 1, 7. Right. Now all that says is that this function, as x approaches 3, the y values are getting closer to 7 from the left and the right. So overall our limit is 7. Nothing fancy. Same story is going to hold if we have logarithms, exponentials, or in example B, trig functions. We're going to plug in pi where our limit's going, cosine of pi minus sine of pi. Evaluate normally using unit circle. So we should have negative 1 minus 0. And simplify, that's obviously negative 1. So the limit as x approaches pi of this function is negative 1. Now this story will get a little bit more interesting with a piecewise function. So on the right, we've got f of x defined in 3 pieces. 3x plus 2 for x values less than or equal to 1. Negative 2x plus 7 for x values between 1 and e. And 4 ln of x plus 1 for x values that are bigger than e. Now we've got a few limits to evaluate down below. First, the limit as x approaches 1 from the left of f of x, and that should be an equal sign, I think. So we're going to try to plug in 1, but we have to plug it in the right spot. So we want to make sure we use the part of our function that allows us to use x values that are less than 1. And that's what our top part of our function allows us to do. We plug in 1 to the top part, 3 to the first plus 2 gets us a value of 5. For our second limit, as x approaches 1 from the right of f of x, again, we want to make sure we plug in 1 to the right location. And it doesn't matter that x is allowed to equal 1 or not allowed to equal 1. We want to make sure we plug it in where x is allowed to be a little bit bigger than 1. So that's the middle part of our function. Plugging in 1, negative 2 times 1 plus 7 should get us 5 again. And in conclusion, if we try to answer the limit as x approaches 1, that takes the evidence from the left and the right and makes a conclusion based off of that evidence. Since both of these limits approach 5, then the limit as x approaches 1 of our function will also be 5. Same story, different x value. On the right, we're going to approach e. First, we'll approach e from the left. So we're going to plug it into the middle portion of our piecewise function because that allows x values less than e. That'll get us negative 2 times e plus 7. Not a lot of simplifying we can do there, so that's all our value should be. If we try to evaluate the limit as x approaches e from the right, we want to make sure that we plug it into the part of the function that allows us to use values of x that are slightly bigger than e. So the bottom part. That'll be 4 natural log of e plus 1. Recalling natural log of e is just 1. Then we'll have 4 times 1 plus 1. So it should result in a limit value of 5. Now, in conclusion, the limit as x approaches e of f of x, that's got to take the evidence of the left and the right limits. And since those do not equal each other at all, then our conclusion has to be that the overall limit as x approaches e of our function does not exist. To see more videos like this, click subscribe. Or to continue your journey through calculus, click the next video on your left.